Good morning, friends. Today we are going to see the next part of this unit, laws of radioactive decay. As we have seen, the natural radioactivity is nothing but the spontaneous emission of the highly penetrating radiation from the heavy elements. Examples: uranium, thorium, polonium, etc. They are called as the parent element, which gives you the new element called as a daughter element by emission of the alpha, beta, gamma radiation after the disintegration. The activity of a substance is measured by the number of radioactive nuclei that disintegrate per second. It may comes for the MCQ. The activity of the substance is measured by the number of radioactive nuclei that disintegrate per second. This disintegrate per second, in short, it is called as a DPS. Okay. Suppose there are the N0 unstable parent nuclei present initially at t is equal to 0, n be the number of nuclei present in the sample at any time or say any instant t. The rate of disintegration of the radioactive nuclei at any instant is proportional to the number of radioactive nuclei present at that instant. That is minus dn by dt is directly proportional to n. Therefore, minus dn by dt is equal to lambda. In proportionality constant is called lambda, which is the decay or cell disintegration constant. Therefore, dn by n is equal to minus lambda dt. On integrating, we get log E n is equal to minus lambda t plus c, where c is the constant of integration. When t is equal to 0, n is equal to n0. Therefore, log E n0 is equal to c. Substituting this equation, we will get log E n is equal to minus lambda t plus log E n0. Log E is equal to n by n0 is equal to minus lambda t. Therefore, n is equal to n0 e raised to minus lambda t. This equation particularly shows that the number of nuclei of radioactive substance decreases exponentially with time. It is called as a radioactive decay law or decay equation. This equation is called as a decay equation. We can rearrange this equation. Therefore, dn by dt is equal to minus lambda n0 e raised to minus lambda t. Therefore, activity of the radioactive substance is given by dn by dt, which is equal to lambda n, which is equal to lambda n0 into e raised to minus lambda t. Activity of any radioactive substance that may come for the MCQ at any instant is proportional to the number of atoms of the radioactive substance present at that instant. Therefore, A is equal to A0 into e raised to minus lambda t, where A0 is the initial activity and A is the activity at time t. Now the disintegration constant, half-life and the mean life that we have seen already. N is equal to n0 e raised to minus lambda t. N by n0 is equal to e raised to minus lambda t. T is equal to 1 upon lambda. Then n upon n0 is equal to e raised to minus 1. Therefore, n is equal to n0 by e. Hence, the disintegration constant is defined as the reciprocal of the time during which the number of atoms of the radioactive substance falls to 1 upon e of its original value. This is the definition of the disintegration constant. Lambda is nothing but the reciprocal. Then the half-life period. The half-life period of the radioactive substance is defined as the time taken by the to disintegrate to the 50% of initial quantity. It again come for the MCQ purpose. T tau is equal to 0.6931 upon lambda, or say tau is equal to log E2. Then average or mean life period. The atoms of the radioactive substance are constantly disintegrating, and thus life of every atom is different. Therefore, the average or mean life period of radioactive substance is equal to the sum of the lives of all atoms. This may come for the MCQ. The sum of the lifetimes of the DN atom is TDN is equal to lambda t n0 e raised to minus lambda t. Since the decay process is statistical, any single atom may have the lifetime of 0 infinity. T is equal to 1 upon lambda. Mean life of the radiation is reciprocal of the disintegration or decay constant. It comes for the MCQ purpose of half life is equal to 0.6 into mean life, and mean life is equal to 1.44 time into half life. These two equations you have to remember. Units of radioactivity, it is expressed in the Curie. It is defined as the activity of any radioactive substance that disintegrate at the rate of 3.7 into 10 raised to 10 dps disintegration per second. That come for the MCQ. Okay, 1 curie is equal to 3.7 into 10 raised to 10 dps. 1 millicurie is equal to 10 raised to minus 3 curie, and 1 microcurie is 10 raised to minus 6 curie. Another unit of the activity is Rutherford, which is defined as the activity of radioactive substance that disintegrate at the rate of 10 raised to 6 dps disintegration. Then another unit is the Becquerel, which is defined as the activity of radioactive substance that disintegrate at the rate of the 1 dps, 1 disintegration per second. Successive radioactive transformation, all nuclei having atomic number greater than the 83 are unstable and disintegrate the emission of the either alpha, beta and the gamma rays. We are not going in detail of this part. After this part, there are the radioactive equilibrium. Ideal equilibrium is there. Okay, secular equilibrium is there, and the transient equilibrium there. Three kinds of the equilibria are observed in the under the different conditions. First is the ideal equilibrium, where activity of the parents becomes equal to activity of the daughter. In the secular equilibrium, if activity of the parent is very long lived, that is the half life of the parent element is too much greater than the half life of the daughter element, then this equilibrium is possible. In short, I am telling, and this type of this transient equilibrium is occur when the daughter is short lived as compared with the parent. Therefore, parent is longer lived compared to the daughter. Then radioactive series, there are the three naturally occurring radioactive series showing the successive transformation: uranium, actinium and thorium. Remaining part we will see in the next lecture. Thank you.